Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Very busy week last week, over the weekend as well. And today we're moving on. So double check with your neighbor, see what they got for that warm-up, please. Warm-up 47. Thank you. All right, good communication. All right, we need we need a mean standard deviation and our bell curve. Whoa. Bye. All right, mean, Diego. What was it? 30? Hands if you got 30. Looks about right. All right, and then we got standard deviation, up and down. Pass someone, Diego, for standard deviation. What was it? 18.95. Hands if you got that. Yes, looks about right. So therefore, our first standard deviation up is 48.95, and below is 11.05. And this is our normal range. All right. Agenda for today, warm-up number 47, measure of variation. I think we're just about done with this section. Today we're going to look at something a little bit adding more to our variance and variation. And I think that's it. From there we're going to be moving on to the next section. So, hopefully for tonight, page 145, numbers 27, 29, and 30 only. Once again, warm-up number 47, measures of variation, page 145, numbers 27, 29, and 30. And just a reminder, our quarter progress is coming up this coming week. So this is a short week. This Thursday is going to be a cutoff for a grade, so make sure you talk to your teachers. People. Bah. All right, here's the code. YTNK5. YTNK5 for today's presentation. Make sure you get that. And once again, your home clue's out of the textbook, but I'm also going to include it here in the slide, so there you go. YTNK5. All right, get a Cornell note ready, please. Our objective for today, I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. And just for the sake of measures of variation, tell your neighbor the definition of measures of variation. See if they remember. Mean that it's a Monday, they're ready to go. All right, so we know what they are, so this is what you should have on your notes. Commonly used measures for variance that tell about the spread of the data. Yes? Yes, Mr. Q. And here are the different measures that we've been using so far. We covered central tendency, mean, median, mode, variation, range, variance, and standard deviation, and we're headed towards position. This is something that we're going to get started this week. Here are the formulas. And we said we have how many total so far? Yeah, 16, right? So, today we're going to be talking about, and by the way, we've been talking about standard deviation and sample variance, and we've been talking about in regards to using those I've been giving you finding the variance and standard deviation for 2 sets of data. Last week I gave you guys some problems on the warm-up involving a student with his quizzes scores and paper scores, right, for 2 assessments. But if you notice, think about it, aren't those the same type of scores? Because they're both what? Pop parties, right? Quizzes scores and paper scores, they're both pop parties. Today we're going to be talking about coefficient of variation. Coefficient of variation is a statistic that helps us with 2 different types of measures. So whenever somebody's talking about 2 different types of data, not related, kind of like the pop party and quizzes, pop party and paper, those are related, but something that's different, we are given, of course, 2 new formulas. So copy these. Let's go. Let's go. So now we're going to have 18 formulas. Let's go, man. It's building up, right? Am I right? Am I right? So the formula starts with CVar. So you remember what CVar stands for? All right, good. Jaden, what does CVar stand for? Yeah, coefficient of variation, yes. And by now you should know each of the components of that formula. So turn to your neighbor, let them know what S stands for, this one, and this one. Good morning, Mr. Q. All right, let's see. Jaden, pass someone. Fernando, what does this stand for? Close. Or let me make it easier. What does this one stand for? Standard deviation. That's it? What? Population, my goodness. I was about to send someone to slap people around. Therefore, what does this one stand for? Sample. Yes, that is correct. So with that said, what do these stand for? Pass someone, please. Mean. What is it? Okay. Sample. Pop. Yes. All right. Last but not least, what does this do to whatever we get with that fraction? Talk to your neighbor, and then Aurelie's going to pass it to someone. What does that do to whatever we get from that equation? All right, Aurelie, pass someone. Diego. That is correct. It turns it into a percent. That's the equalizer. So it doesn't matter if they're talking about different types of data. Once you turn it into a percent, it kind of like brings it to an even bar. Okay? So we're going to be using these 2. And let's get started. Example Q. It says, the mean of the number of sales of cars over 3-month period is 87, and the standard deviation is 5. The mean of the commission is 52.25, and the standard deviation is 773. Compare the variations of the 2. So you don't have to copy the entire problem. Let's start with the formula. Question. sales of cars over 3-month period with the commissions. Now, are they talking about the entire world? No, so it's the sample, right? So let's write our formula. CVar equals, what do I write? Diego S X bar times 100. So with blue, we're going to do the sales of the cars, and with green, we're going to talk about the commission. So with blue, CVar equals, and with green, we're going to talk about commission. All right, so let's see. For sales of cars, tell your neighbor what to write for S and what to write for the mean. All right, help us out, Briseida. 87 for what? On the bottom for the X bar, yes. And how about for the S? 5, yes. So we're going to write 5 and 87. So Briseida gave us that one. Tell your neighbor what you're going to do for commission. What do you write for commission? Pass that one, Briseida. Illy. $773. 52.25. That is correct. So the mean is that, and standard deviation is this. So that means this is our X bar, and this is our S. All right? Calculators calculate. What'd you get for the coefficient variation of the sales of cars? Joseph, what'd you get? What is it? What was it? 5.74%. Okay. How about for the coefficient variation of commission? Pass someone, Joseph. Dylan. $14.79%. Hands, have you got that? All right, so question. Which one has the highest variation, guys? Just by looking at the percentage. Which one has more, you think that's going to vary from in regards to predicting some of the sales or some of the commission? What do you guys think? Yeah, the commission. Because it's what? Higher. The higher the percent, the more it varies in regards to its consistency. All right, from 1 to 5, how comfortable are you with CVar? Yeah? You're like, it's just applying the formula. All right, let's do another one. Actually, send me your notes. Give me a second. All right. Let's move on. Example, mega Q. So I'm going to send you this one, and I want you to label on the screen what is what. Give me a second. All right, so it reads, the mean of the number of pages of a sample of Women's Fitness magazine is 132, with a variance of 23. 23, Michael Jordan. The mean for the number of advertisements of a sample of Women's Fitness magazine is 182, with a variance of 62. Compare the variations. Okay, so with that said, get us started with the formula without looking at your paper. Let's see, how about, who haven't we called on in a while? Who? Jaden, go. CVar equals, no, just the formula first so we can get started. That is correct. So once again, I'm going to use blue for the number of pages in the magazine. Number of pages in the magazine. And this is the mean. So CVar equals blank times 100. And green for the green for the number of advertisements. The mean advertisements and variance for that same magazine, CVar. Okay. So, let's see. What do I write for the first one? Get us started. Oh, Jaden, pass him one. Diego, tell me what you write for the first one. 23, okay. Over 132. Hands, have you got that? That'll be correct. Look up to the screen. Look up to the screen. If this was a variance. But what is that? Tell you never, what is this? What does the S stand for? Standard deviation. So tell you never what to do with the 23. Looks like Illy's got it. What do we do with a 23, Illy? Yeah, square root. So on your formula, make sure you put a little square root because they're giving us the variance instead of a standard deviation. So with that said, what do I write for the second formula? Diego, pass it to someone. Fernando. Bam. Let's go. That is correct. Because once again, 62 is the variance. So Fernando, okay. Fernando gave us a square root of 62, and then with the mean of 182. All right, find me those numbers, please. All right. For the first one, Lenny, what'd you get for CVar of the number of pages? Okay. Help her out, Mia, Victoria. The blue one? Number of pages? Square root of 23 divided by 132 times 100. 3.63. Hands, have you got that? All right, that's percent. About for the second one, help her out. Let's see, how about Alexia? What'd you get? You haven't got there yet? All right. Clarissa, what'd you get for this one? Square root of 62 divided by 182 times 100? No? Oh my goodness. Jael? I'm going to do like you guys say. Bruh. Oh my goodness. Alright. Briseida got it? Alright. Briseida, what'd you get? What is it? 4.32%. Looks about right. So, tell your neighbor which one has the more variance. Obviously. Which one has the more variance, everyone? Yeah, which is what? What does that represent? All right, so let's write a conclusion. The number of advertisement in fitness magazine has a higher variance. $10Q. All right, from 1 to 5, I'll come provide you with that. We good, you right? All right, so I gave you the two looks. The one with standard deviation, which is straightforward, and the one that they give us with a variance. What do we need to do? What was the only difference? The square root, right? All right. So, send me your notes. All right. Next, example super Q. It reads, the mean and standard deviation of marks obtained by 40 students of a class in 3 subjects, math, science, and social science, are given below. Which of the 3 subjects shows highest variation? All right. So by looking at this, you should have the data there. You should know how to use your formula. Therefore, I want you to write, look up, right next to each, should I say, add another column for the CVar, for each of these. Let's see, that shouldn't take you more than 3 minutes, yeah? Yes, Mr. Q. All right. I'll give you some time, and then I'll send you a screen so you can send me your work. All right, conclusion. Tell your neighbor the conclusion, please, and then we'll have someone enlighten us. Conclusion. Hey, we haven't called on Caleb lately, right? All right, tell your neighbor what was your conclusion, then Caleb's going to enlighten us. Conclusion. Man, you guys are so talkative today. What is it, because it's Monday? And tomorrow, because it's Tuesday? Oh, my goodness. We have a 4-day week this week, huh? Let's go. All right, Caleb, conclusion. Ooh, hands if you agree with that. That is correct. Science has the highest variation. All right. So from 1 to 5, I'll come to you with CVar, comparing 2 different types of measures. 5, 5, 5. Okay. So I'm going to stop the video here. And for those that are following along on video, here's some practice problems. And you can do those on your own. So there you go. All right. If you need extra support, come by my office hours. Office hours. Anyways, bye.